What if the solar system, the place we call our cosmic neighborhood, holds secrets that even the brightest minds on Earth cannot fully explain? From mysterious signals echoing through the void to bizarre structures on distant planets, the universe is packed with phenomena that defy our understanding. In this video, we're diving into 25 of the most puzzling mysteries lurking in our solar system. These enigmas challenge everything we think we know about space, from the forces that shape it to the possibilities of life beyond Earth. So get ready to embark on a journey into the unknown, where every discovery raises more questions than answers. Stay with us, because by the end of this video, you'll see the solar system in a whole new light, and maybe even question what's truly out there. Now let's dive into our first phenomenon, something that has left scientists scratching their heads for years. It's called the dark flow. Imagine if you could see the entire universe in motion, with galaxy clusters all moving together in one specific direction, as if being pulled by an invisible force. That's exactly what astronomers observed. This mysterious movement defies everything we know about gravity and the distribution of matter in the universe. The dark flow was first discovered in 2008 when researchers used the cosmic microwave background, the faint afterglow of the Big Bang, to map the motion of galaxy clusters. What they found was astonishing. Hundreds of these clusters, located billions of light years away, were all streaming toward the same region of space at incredibly high speeds. This shouldn't happen. According to our current understanding of physics, the gravitational forces in the universe should be balanced, with no single direction pulling everything toward it. So, what could be causing this? One theory suggests that the dark flow is the result of something massive and completely unknown lying beyond the observable universe. It could be a colossal structure or a region of space with a gravitational pull so strong that it's tugging on everything around it. Another idea is that it's evidence of other universes, part of a multiverse, exerting their influence on ours. Yet, despite these intriguing possibilities, the dark flow remains unexplained. Its existence challenges our understanding of the cosmos and raises profound questions about what lies beyond the edges of our observable universe. Could there be entire realms of space and time we've yet to discover? As we continue to explore this mystery, one thing is certain: the dark flow reminds us just how much we still have to learn about the vast, enigmatic expanse of space. And with that, let's move on to our next phenomenon, another mystery that has puzzled scientists for decades. Now, let's turn our attention to a mystery that has captivated astronomers and alien enthusiasts alike: the WOW signal. Imagine receiving a radio signal from deep space so powerful and unusual that it stood out from the constant cosmic noise. That's exactly what happened on the evening of August 15, 1977. When Ohio State University's Big Ear radio telescope detected something extraordinary. The signal lasted for 72 seconds and was so strong that astronomer Jerry Amon circled it on the printout, writing "Wow" next to it, a name that's stuck ever since. What made this signal so remarkable was its frequency of 1,420 MHz, a range reserved for scientific use and free from interference by Earth's technology. It seemed to originate from a region of space near the constellation Sagittarius, but despite repeated attempts, it has never been detected again. Scientists have tried to explain the WOW signal in various ways. One possibility is that it came from a natural celestial event, like a comet or a star. However, no known natural phenomenon perfectly matches its characteristics. Another theory, and the one that sparks the most excitement, is that it could have been a deliberate transmission from an extraterrestrial civilization. If true, this would be one of the most significant discoveries in human history. Despite decades of searching, the source of the WOW signal remains a mystery. It's a tantalizing reminder that the universe is full of signals and sounds we're only beginning to decode. Could this have been our first contact with intelligent life beyond Earth? Or is it just one of the many cosmic puzzles waiting to be solved? As we continue to listen to the stars, the WOW signal stands as a beacon of the unknown, urging us to keep exploring. And with that, let's move on to our next cosmic enigma, one that brings us closer to home but is no less perplexing. Shifting our focus to our closest celestial neighbor, we uncover another mystery that has puzzled scientists for decades: the moon's magnetic field. Today, the moon is a barren, airless world with no global magnetic field, but evidence suggests this wasn't always the case. Ancient lunar rocks brought back by Apollo astronauts contain traces of magnetism, indicating that the moon once had a magnetic field similar to Earth. So, how did the moon generate this magnetic field, and why did it vanish? Scientists believe that the moon's magnetic field was powered by a process called a dynamo, which requires a molten, swirling metallic core. Early in its history, the moon's core may have been hot enough to create this dynamo effect, producing a magnetic field that lasted for around 1 billion years. However, as the moon's core cooled, the dynamo shut down and the magnetic field faded away. But here's the twist: some researchers argue that the moon's small size and rapid cooling shouldn't have allowed a dynamo to exist for so long. This has led to alternative theories, such as impacts from massive asteroids or interactions with Earth's gravitational pull, which could have temporarily reignited the moon's magnetic activity. The implications of this mystery go beyond the moon itself. Understanding how and why the moon lost its magnetic field could shed light on the evolution of other rocky bodies in the solar system, including Mars, which also lost its magnetic field billions of years ago. It's a reminder that even our closest cosmic companion holds secrets that challenge our understanding of planetary history. As we continue to study the moon, its ancient magnetic field remains a fascinating puzzle, inviting us to explore not just its surface but the depths of its past. Next, we'll delve into a gravitational anomaly that's pulling galaxies toward it, hidden behind the Milky Way, the Great Attractor. Now, let's turn our attention to a cosmic enigma that's pulling entire galaxies toward it, yet remains shrouded in mystery: the Great Attractor. Hidden behind the dense plane of the Milky Way, this gravitational anomaly exerts an immense pull on our galaxy and many others in its vicinity, creating a massive flow of matter in its direction. The Great Attractor was first discovered in the 1970s when astronomers noticed that galaxies, including our own, were moving toward a specific point in space at astonishing speeds. This motion couldn't be explained by the known distribution of matter in the universe, leading scientists to theorize the existence of a massive, unseen source of gravity. However, studying the Great Attractor is no easy task. Its location lies behind the Milky Way's central bulge, a region filled with stars, dust, and gas that obscures our view. This zone of avoidance makes it incredibly difficult for optical telescopes to observe what lies beyond. To overcome this, astronomers have turned to other wavelengths, such as X-rays and radio waves, which can penetrate the galactic haze. Current estimates suggest that the Great Attractor is a concentration of mass equivalent to tens of thousands of Milky Ways, likely consisting of a massive cluster of galaxies and dark matter. Yet, even with this knowledge, the full nature of this gravitational behemoth remains unclear. Some researchers believe it could be part of an even larger structure, such as the Shapley supercluster, which lies beyond it and may be amplifying its pull. The Great Attractor challenges our understanding of the universe's large-scale structure and the forces shaping it. As we continue to map this hidden region, each discovery brings us closer to unraveling one of the cosmos's most profound mysteries. Next, we'll explore a phenomenon that captured the public's imagination and sparked debates about extraterrestrial life: the face on Mars. Shifting our gaze to the red planet, we encounter a phenomenon that has captivated imaginations and fueled debates for decades: the face on Mars. This intriguing feature, first spotted in the 1970s by the Viking 1 orbiter, appeared to depict a humanoid face staring up from the Martian surface. The image sparked widespread speculation, with some suggesting it was evidence of an ancient alien civilization, while others argued it was merely a trick of light and shadow. NASA's initial photographs of the face were low resolution, making it difficult to discern its true nature. However, as technology advanced, subsequent missions like the Mars Global Surveyor and the Mars Reconnaissance Orbiter captured higher quality images. These revealed that the formation was likely a natural mesa, shaped by erosion and weathering over millions of years. The play of light and shadow in the original image had created the illusion of facial features, leading to the initial misinterpretation. Despite these findings, the face on Mars continues to hold a special place in popular culture. It has inspired countless books, documentaries, and even conspiracy theories, becoming a symbol of humanity's fascination with the idea of extraterrestrial life. The debate over its origins, though largely settled by scientific evidence, still captures the imagination of those who wonder if Mars might have once harbored intelligent beings. NASA's exploration of the region around the face has also revealed other intriguing geological features, such as nearby pyramid-like structures and valleys that may have once been carved by flowing water. These discoveries have added depth to our understanding of Mars' geological history, even as they remind us of the planet's potential to surprise and mystify. The face on Mars serves as a reminder of how easily our perceptions can be shaped by the unknown. It challenges us to look beyond first impressions and seek a deeper understanding of the cosmos. Next, we'll examine another baffling feature in our solar system, the mysterious hexagon on Saturn's north pole. Turning our attention to the ringed giant of our solar system, we encounter one of the most baffling atmospheric features ever observed, the giant hexagon swirling at Saturn's north pole. Discovered by the Voyager missions in the early 1980s and later studied in greater detail by the Cassini spacecraft, this enormous six-sided storm measures about 20,000 miles across, large enough to fit 4 Earths side by side. Its perfectly geometric shape is unlike anything seen in the atmospheres of other planets, leaving scientists both fascinated and puzzled. Unlike typical storms on Earth or other planets, which are circular or irregular in shape, Saturn's hexagon has maintained its sharp edges and stable structure for decades. This persistent geometric pattern defies our understanding of atmospheric dynamics, as natural processes usually smooth out such precise shapes over time. The hexagon's sides are each longer than the diameter of Earth, and its rotation period matches Saturn's own day length, adding another layer of mystery to its behavior. Scientists have proposed several theories to explain this phenomenon. Some suggest that the hexagon is the result of jet streams moving at different speeds, creating a standing wave pattern that forms the hexagonal shape. Others speculate that it could be linked to deep atmospheric processes or even the planet's internal rotation. However, none of these explanations fully account for the hexagon's stability or its precise geometry, leaving it as one of the most enduring enigmas in planetary science. Adding to the intrigue, the hexagon is not just a visual anomaly. Inside this colossal structure, smaller storms swirl and churn, creating a dynamic and chaotic environment. The Cassini spacecraft also revealed that the hexagon extends deep into Saturn's atmosphere, hinting at complex interactions between atmospheric layers that we are only beginning to understand. Saturn's hexagon serves as a striking reminder of how much we still have to learn about the atmospheres of distant worlds. Its existence challenges our assumptions about planetary weather and inspires us to keep exploring the unknown. Next, we'll journey to Earth's own backyard to investigate the mysterious Tunguska event, a massive explosion that shook Siberia in the early 20th century. Now, let's shift our focus from the skies of Saturn to a dramatic event that unfolded right here on Earth. On the morning of June 30th, 1908, a massive explosion rocked the remote region of Tunguska in Siberia. Witnesses described a blinding flash of light followed by a shockwave so powerful that it flattened over 2,000 square kilometers of forest, an area roughly the size of a major city. The force of the explosion was estimated to be 1,000 times greater than the atomic bomb dropped on Hiroshima, yet astonishingly, no crater was found at the site. This absence of a crater has fueled decades of debate about what actually caused the Tunguska event. The most widely accepted theory is that it was the result of a meteor or comet exploding in the atmosphere before it could reach the ground. Such an airburst would explain the widespread devastation and the lack of a crater, as the object would have disintegrated several miles above the Earth's surface. However, this explanation raises its own set of questions, such as why no significant fragments of the object have ever been recovered. Alternative theories have emerged over the years, ranging from the scientifically plausible to the outright speculative. Some researchers propose that the event was caused by a small black hole passing through Earth, though this idea has been largely dismissed due to the lack of supporting evidence. Others suggest it could have been the result of a release of natural gas from the Earth's crust, though this doesn't fully account for the explosive force or the eyewitness accounts of a bright, fiery object in the sky. What makes the Tunguska event particularly intriguing is its lasting impact on scientific inquiry. It remains one of the most powerful natural explosions in recorded history and serves as a stark reminder of the potential dangers posed by near-Earth objects. Scientists continue to study the Tunguska site, using modern technology to analyze soil samples and search for clues that might shed light on this century-old mystery. As we explore deeper into the unknown, the Tunguska event stands as a testament to the unpredictable and awe-inspiring forces at play in our universe. Up next, we'll venture to the edge of our solar system to unravel the mystery of the Kuiper Cliff, where objects suddenly become scarce, leaving scientists searching for answers. As we journey further into the outer reaches of our solar system, we encounter a puzzling phenomenon known as the Kuiper Cliff. This mysterious boundary marks the edge of the Kuiper Belt, a region filled with icy bodies and dwarf planets like Pluto. But here's the catch: beyond a certain point, the number of objects drops off dramatically, almost as if something is keeping them from venturing further. Scientists first noticed this sudden drop-off in the late 1990s, and it's been a head-scratcher ever since. The Kuiper Belt is supposed to gradually thin out as you move away from the sun, but instead there's a sharp cutoff, a cliff where objects become incredibly rare. This doesn't align with our current understanding of how the solar system formed, leading to some fascinating theories. One popular explanation is the possibility of an undiscovered planet lurking in the distant reaches of our solar system. Dubbed Planet 9, this hypothetical world could be exerting a gravitational pull that clears out objects beyond the Kuiper Cliff. While no direct evidence of Planet 9 has been found, its existence would neatly explain the strange distribution of objects in the Kuiper Belt. Another theory suggests that the Kuiper Cliff might be the result of early solar system dynamics. During the formation of the planets, gravitational interactions with giant planets like Neptune could have scattered objects outward, creating a boundary where the density of objects drops off sharply. What makes the Kuiper Cliff so intriguing is that it challenges our understanding of the solar system's outer limits. It's a reminder that even in our own cosmic backyard, there are still mysteries waiting to be unraveled. As telescopes and technology continue to improve, we may one day uncover the true cause of this enigmatic boundary. Now, let's shift our gaze to Mars, where another mystery awaits: the intermittent detection of methane in its atmosphere. Could this be a sign of life, or is there a geological explanation? Stick around as we explore the possibilities. Turning our attention to the red planet, we encounter one of Mars' most tantalizing mysteries: the detection of methane in its atmosphere. Methane, a gas often associated with life on Earth, has been spotted on Mars in unpredictable bursts, sparking intense curiosity and debate among scientists. Could this be a sign of microbial life beneath the Martian surface, or is there a purely geological explanation? The story of Martian methane begins with observations made by rovers and orbiters over the past 2 decades. Instruments like the Curiosity rover have detected methane at varying concentrations, sometimes spiking unexpectedly before dropping back to almost undetectable levels. What makes these findings so intriguing is that methane is a gas that doesn't last long in the Martian atmosphere. It breaks down quickly when exposed to sunlight. So, if methane is being detected, it suggests there's an active source replenishing it. One possibility is that microbial life, similar to certain bacteria on Earth, could be producing methane as a byproduct of their metabolism. If such life exists, it might thrive in subsurface environments where liquid water could persist. The idea of life on Mars, even in microbial form, is undeniably thrilling, but it's far from proven. On the other hand, methane could also be produced through geological processes. Mars is home to volcanoes, both ancient and potentially still active, and certain types of rock can produce methane when they interact with water. For example, a process called serpentinization, where water reacts with olivine-rich rocks, could release methane without any biological involvement. The intermittent nature of the methane detections adds another layer of complexity. Why does the methane appear and disappear so unpredictably? Some scientists think it could be related to seasonal changes or the release of gas from underground reservoirs. Others suggest that the methane might be trapped beneath the surface, only escaping during specific geological events. The debate over Martian methane is far from settled, and it's one of the key questions that future missions to Mars aim to answer. Missions like the ExoMars program and NASA's Perseverance rover are equipped with advanced instruments designed to study methane and its potential sources in greater detail. This mystery reminds us that Mars, though barren on the surface, may still hold secrets that could reshape our understanding of life in the universe. Whether the methane is a sign of life or a geological curiosity, it's a puzzle that continues to captivate scientists and space enthusiasts alike. Next, we venture even further into the cosmos to explore the origins of the Oort cloud, the distant and enigmatic boundary of our solar system. What mysteries lie in this icy realm, and how did it come to be? Stay with us as we uncover the secrets of this cosmic frontier. Now, let's journey to the farthest reaches of our solar system, where a vast and mysterious cloud of icy objects resides, the Oort cloud. This distant region, thought to be the outer boundary of our cosmic neighborhood, is shrouded in mystery, from its origins to its role in shaping the solar system as we know it. The Oort cloud is believed to be a spherical shell of icy debris, stretching from about 2,000 astronomical units from the Sun to as far as 100,000 astronomical units. For context, 1 astronomical unit is the average distance between Earth and the Sun. This immense distance makes the Oort cloud one of the most inaccessible regions of our solar system, and its existence is largely inferred rather than directly observed. So, how did the Oort cloud come to be? One leading theory suggests it formed from the leftover material of the early solar system. As the planets took shape billions of years ago, gravitational interactions flung icy remnants outward, scattering them to the farthest reaches of the Sun's influence. Over time, these icy bodies settled into the spherical shell we now call the Oort cloud. Another intriguing idea is that some of the material in the Oort cloud may have been captured from other star systems. During the Sun's early history, it was part of a dense star cluster, and interactions with neighboring stars could have allowed for an exchange of icy objects. This could explain why the Oort cloud contains such a vast and diverse collection of comets and other icy bodies. The Oort cloud plays a crucial role in the solar system as the source of long-period comets. These comets, which take thousands or even millions of years to orbit the Sun, are thought to originate from this distant reservoir. Occasionally, Gravitational disturbances from passing stars or the Milky Way's tidal forces send these icy bodies hurtling inward, lighting up our skies as they approach the Sun. Despite its importance, the Oort cloud remains one of the least understood regions of our solar system. Its extreme distance makes direct observation nearly impossible with current technology, leaving scientists to rely on computer models and the study of comets to piece together its story. Questions abound: how exactly did the Oort cloud form? How many objects does it contain, and what are their compositions? Could there be undiscovered planets or other large bodies lurking in its depths? These are just some of the mysteries that continue to puzzle astronomers. As our exploration of the solar system progresses, the Oort cloud remains a tantalizing frontier, a reminder of how much we still have to learn about the cosmos. Next, we'll turn our attention to another perplexing phenomenon: the unexpected behavior of the Pioneer spacecraft, and what it reveals about the forces at work in our solar system. Shifting our focus to a puzzle closer to home, we encounter the strange case of the Pioneer spacecraft and their unexpected behavior. Launched in the early 1970s, Pioneer 10 and Pioneer 11 were designed to explore the outer planets and beyond. While their missions were groundbreaking, they left scientists with a mystery that took decades to unravel: the Pioneer anomaly. As these spacecraft ventured farther into space, scientists noticed something odd. Both Pioneers were slowing down slightly more than expected, as if an unseen force was acting upon them. This deceleration was tiny, just a fraction of a nanometer per second squared, but it was consistent and defied the known laws of physics. The anomaly sparked a flurry of research and debate. Could it be a sign of an unknown force in the solar system? Some speculated it might be evidence of dark matter or even a modification to Einstein's theory of gravity. Others wondered if it was a result of something as mundane as heat radiation from the spacecraft themselves. After years of investigation, the most plausible explanation turned out to be surprisingly simple. The spacecraft's thermal radiation, emitted unevenly due to their design, was exerting a tiny but measurable force. This thermal recoil effect was enough to account for the observed deceleration. While this solution may not be as thrilling as new physics, it highlights the importance of meticulous analysis in solving cosmic mysteries. The Pioneer anomaly serves as a reminder that even the smallest discrepancies can lead to big questions. It also underscores the ingenuity of scientists in unraveling such puzzles. While the anomaly has been resolved, it remains a fascinating chapter in the history of space exploration. Next, we'll venture into the realm of Uranus and its enigmatic moons, whose peculiar orbits and features continue to intrigue astronomers. Now, let's turn our attention to the distant reaches of the solar system, where Uranus and its intriguing moons await. This ice giant is surrounded by a collection of moons that defy the norms we've come to expect from other planetary satellites. Unlike the orderly, circular orbits of most moons, those of Uranus are tilted dramatically, aligning with the planet's own peculiar axial tilt. This unique arrangement has puzzled scientists for decades, offering a window into the chaotic early days of our solar system. The most notable of Uranus's moons is Miranda, often described as one of the strangest objects in our cosmic neighborhood. Its surface is a patchwork of deep canyons, towering cliffs, and craters, resembling a jigsaw puzzle rather than a typical moon. One theory suggests that Miranda may have been shattered by a massive impact in the past, only to slowly reassemble itself over time. This would explain its chaotic terrain, but the specifics of its history remain a subject of debate. Another striking feature of Uranus's moons is their retrograde orbits. Unlike most moons that orbit in the same direction as their planet's rotation, some of Uranus's satellites move in the opposite direction. This unusual behavior hints at a tumultuous past, possibly involving collisions or captures from the outer solar system. These moons may not have formed alongside Uranus, but were instead drawn into its gravitational embrace during its early history. the composition of these moons also sets them apart. Many are made of a mix of rock and ice, with some even showing signs of potential subsurface oceans. Ariel, for instance, has smooth plains that suggest past geological activity, possibly driven by tidal forces from Uranus. These features raise intriguing questions about the potential for life in such distant and icy worlds. The moons of Uranus are a testament to the solar system's dynamic and often violent history. Their unusual orbits, chaotic surfaces, and diverse compositions challenge our understanding of how moons form and evolve. While we've learned much from telescopic observations and data from the Voyager 2 spacecraft, there's still so much to uncover about these enigmatic worlds. Next, we'll explore another cosmic puzzle that has baffled scientists for decades: the faint young sun paradox, a mystery that challenges our understanding of Earth's early climate. Shifting our focus to an ancient enigma that has puzzled scientists for decades, we encounter the faint young sun paradox. This mystery revolves around the contradiction between the sun's early luminosity and the presence of liquid water on Earth billions of years ago. When the sun was young, it was significantly dimmer, emitting only about 70% of the energy it does today. According to this, Earth should have been a frozen wasteland, incapable of supporting liquid water or the conditions necessary for life to emerge. Yet, geological evidence tells a different story. Rocks from that era show clear signs of liquid water, suggesting a much warmer climate than the faint sun would allow. So, how did Earth stay warm enough for water to flow? One leading theory points to the planet's early atmosphere, which may have been rich in greenhouse gases like carbon dioxide and methane. These gases could have trapped enough heat to compensate for the sun's weakness, creating a stable environment for liquid water to exist. Another possibility is that Earth's atmosphere had a different composition, perhaps with higher levels of hydrogen or nitrogen, which could have played a role in warming the planet. Some scientists have even proposed that Earth's albedo, or reflectivity, was much lower in the past, allowing it to absorb more sunlight. Alternatively, the young Earth might have had a thicker atmosphere, which could have provided additional insulation against the cold. There's also the intriguing idea that early life forms, such as methane-producing microbes, contributed to the greenhouse effect, further stabilizing the climate. Despite these theories, the faint young sun paradox remains unresolved. Each explanation has its own challenges, and none fully account for the complexity of Earth's early climate. This paradox not only challenges our understanding of planetary science, but also raises questions about the potential for life on other worlds. If Earth could stay warm under a faint sun, could other planets in similar conditions have supported life as well? As we continue to unravel this mystery, it reminds us that the history of our solar system is far from straightforward. Next, we'll turn our attention to another intriguing glow in the sky: the zodiacal light, a phenomenon that has fascinated astronomers for centuries. Now, let's turn our gaze to a celestial phenomenon that has captivated skywatchers for centuries: the zodiacal light. This ethereal glow, often seen as a faint, pyramid-shaped light stretching upward from the horizon after sunset or before sunrise, has long been a source of wonder and mystery. Unlike the familiar twinkle of stars or the steady glow of the moon, the zodiacal light is far more subtle, often requiring a dark, clear sky to be fully appreciated. The light owes its existence to a vast cloud of dust particles scattered throughout the inner solar system. These particles, remnants of comets and asteroids, reflect sunlight, creating the soft, diffuse glow we observe. Interestingly, the name zodiacal light comes from its appearance along the plane of the zodiac, the band of sky through which the sun, moon, and planets appear to travel. But where does all this dust come from? Scientists believe it's a byproduct of cosmic collisions and the gradual breakdown of larger bodies. Comets, for instance, leave behind trails of dust as they pass through the inner solar system, while asteroids grind against each other, producing fine particles. Over time, these particles accumulate, forming the zodiacal cloud, a vast pancake-shaped structure that spans millions of miles. The composition of this dust is equally fascinating. Studies have shown it contains silicates, metals, and other minerals, much like the material found in comets and asteroids. Some researchers have even detected water ice within these particles, hinting at their potential role in delivering water to Earth during the planet's early history. Despite its beauty, the zodiacal light remains a mystery in some ways. For instance, why does the dust cloud maintain its structure instead of dispersing or clumping together? Some theories suggest the gravitational influence of the planets, particularly Jupiter, helps shape and stabilize the zodiacal cloud. Others propose that the Sun's radiation pressure plays a key role in keeping the particles evenly distributed. The zodiacal light isn't just a curiosity for astronomers, it also offers clues about the history and evolution of our solar system. By studying its composition and distribution, scientists can learn more about the processes that shape the planets and other celestial bodies. As we marvel at this gentle glow in the night sky, it reminds us that even the smallest particles can tell a profound story. Next, we'll dive into the rings of Saturn, another enigmatic feature of our cosmic neighborhood. Shifting our focus to one of the most iconic features of our solar system, let's explore the enigmatic rings of Saturn. These dazzling bands of ice and rock have fascinated astronomers and casual stargazers alike for centuries, yet their origin and age remain subjects of intense debate. While they appear as a single, solid structure from a distance, Saturn's rings are actually composed of countless individual particles, ranging in size from tiny grains of dust to massive boulders. The composition of these particles is predominantly water ice, mixed with traces of rock and dust. This icy makeup gives the rings their brilliant, reflective appearance, making them one of the most striking sights in the night sky. However, despite their beauty, the rings are incredibly thin. Some sections are less than 1 kilometer thick, making them seem almost delicate in comparison to their vast width. One of the biggest mysteries surrounding Saturn's rings is their age. For years, scientists believed the rings were as old as the planet itself, formed around 4.5 billion years ago alongside the rest of the solar system. However, recent data from the Cassini spacecraft has challenged this view. Measurements of the rings' mass and the rate at which they are being bombarded by micrometeoroids suggest they could be much younger, perhaps only a few 100 million years old. This raises the question, if the rings aren't ancient, how did they form? One leading theory suggests they are the remnants of a destroyed moon. According to this idea, a former moon of Saturn, possibly as large as one of its current moons, was torn apart by the planet's immense gravitational forces. The debris from this catastrophic event could have gradually settled into the ring system we see today. Another theory proposes that the rings formed from the remnants of a passing comet or asteroid that was captured by Saturn's gravity and subsequently shattered. The evolution of the rings is another area of intrigue. Over time, the particles within the rings are subjected to gravitational forces from Saturn's moons, which create gaps and structures within the rings. For example, the Cassini division, a prominent gap in the rings, is thought to be caused by the gravitational influence of the moon Mimas. Additionally, the rings are gradually losing material, with some scientists estimating they could disappear entirely in the next 100 million years. Studying Saturn's rings not only helps us understand the planet itself, but also provides insights into the processes that shape planetary systems. As we continue to explore this celestial wonder, it reminds us that even the most familiar features of our solar system still hold secrets waiting to be uncovered. Next, we'll take a closer look at the moon's origin and the theories surrounding its formation. Turning our attention to Earth's closest celestial companion, let's delve into the enduring mystery of the moon's origin. For decades, scientists have been captivated by the question of how our moon came to be. and while the most widely accepted explanation is the giant impact hypothesis, the story is far from settled. According to this theory, around 4.5 billion years ago, a Mars-sized object, often referred to as Theia, collided with the early Earth. The impact was so colossal that it ejected a massive amount of debris into orbit around our planet. Over time, this debris coalesced to form the Moon we know today. The giant impact hypothesis explains many of the Moon's characteristics, such as its composition, which is strikingly similar to Earth's outer layers. However, it doesn't account for everything. For instance, if the Moon formed from a violent collision, why does it lack volatile elements like water and potassium, which should have been present in the debris? This discrepancy has led some scientists to propose alternative theories. One such idea suggests that the Moon formed from a series of smaller impacts rather than a single cataclysmic event. This multiple impact theory posits that over time, repeated collisions with Earth created clouds of debris that eventually merged to form the Moon. Another intriguing hypothesis proposes that the Moon was once part of Earth itself, forming from a chunk of our planet that was flung into orbit due to Earth's rapid rotation. Recent discoveries have added even more layers to this debate. For example, analysis of lunar rocks brought back by the Apollo missions has revealed subtle differences in the isotopic compositions of Earth and the Moon, challenging the notion that the Moon formed entirely from Earth's material. Additionally, studies of the Moon's interior suggest it may have had a much more complex geological history than previously thought, including the possibility of an ancient magma ocean. Despite these advancements, the Moon's origin remains one of the solar system's most hotly debated topics. Each new piece of evidence seems to raise as many questions as it answers, keeping scientists on a quest for clarity. Understanding the Moon's formation isn't just about solving a cosmic puzzle, it's about uncovering the secrets of Earth's early history and the processes that shaped our planetary neighborhood. Next, we'll explore another baffling mystery, the missing baryon problem and its implications for our understanding of the universe. Shifting our gaze from the Moon to the vast expanse of the cosmos, we encounter one of the most perplexing mysteries in modern astrophysics, the missing baryon problem. Baryonic matter, which includes protons, neutrons, and other familiar particles, makes up everything we can see: stars, planets, galaxies, and even ourselves. Yet, when scientists tally up all the baryonic matter in the universe, they find that a significant portion of it is unaccounted for. This discrepancy has left cosmologists scratching their heads for decades. The mystery begins with the Big Bang, which produced a predictable amount of baryonic matter. But when astronomers measure the matter in the universe today, they only find about half of what the theory predicts. So where did the rest go? One leading theory suggests that the missing baryons are hiding in a cosmic web of hot, diffuse gas known as the warm-hot intergalactic medium, or WIM. This gas is so faint and spread out that it's incredibly difficult to detect with traditional telescopes. Efforts to locate this elusive matter have relied on innovative techniques. For example, astronomers use the light from distant quasars, which passes through the WIM, to detect its presence indirectly. When this light travels through the gas, it leaves behind distinct absorption lines like fingerprints that reveal the gas's properties. Additionally, space telescopes equipped with X-ray instruments have been used to search for the faint glow of this hot gas between galaxies. Despite these advances, the missing baryons remain frustratingly elusive. Some scientists speculate that they could be hiding in regions of space that are even more challenging to observe, such as the outskirts of galaxy clusters or in the voids between cosmic structures. Others have proposed that our understanding of the universe's composition might need revisiting, hinting at the possibility of unknown physical processes at work. The implications of solving this mystery are profound. Finding the missing baryons could help us refine our understanding of the universe's structure and evolution, shedding light on the processes that shaped galaxies and other large-scale features. It could also provide clues about the nature of dark matter and dark energy, the two dominant yet enigmatic components of the cosmos. As we continue to explore this enigma, one thing is clear. The missing baryon problem is a reminder of how much we still have to learn about the universe. Up next, we'll venture deeper into the solar system to examine another intriguing puzzle, the mysterious cores of Uranus and Neptune. Turning our attention to the outer reaches of the solar system, we find ourselves facing yet another cosmic enigma, the mysterious cores of Uranus and Neptune. These ice giants, often overshadowed by their larger gas giant siblings, Jupiter and Saturn, hold secrets that continue to baffle scientists. Unlike the gas giants, whose compositions are relatively well studied, the interiors of Uranus and Neptune remain shrouded in uncertainty. What exactly lies at the heart of these distant worlds? The cores of Uranus and Neptune are believed to be composed of a mix of rock, ice, and possibly exotic materials, but the precise details are far from clear. One of the biggest challenges in understanding these planets is the lack of direct data. Only one spacecraft, Voyager 2, has ever flown by these ice giants, and its brief encounters provided only a glimpse of their complex structures. Since then, our knowledge has relied heavily on telescopic observations and theoretical models. One prevailing theory suggests that the cores of these planets might be surrounded by layers of high-pressure ice and liquid, creating conditions unlike anything found on Earth. This slushy mix of materials could generate unique magnetic fields, which in the case of Uranus are tilted at an unusual angle compared to the planet's rotational axis. Neptune's magnetic field, while less tilted, is equally puzzling with its offset from the planet's center. These anomalies suggest that the processes occurring deep within these planets are vastly different from those in other solar system bodies. Another mystery lies in the heat emitted by these planets. Uranus, for instance, emits far less heat than expected, while Neptune radiates significantly more. This discrepancy has led scientists to speculate about the nature of the internal dynamics driving these ice giants. Could there be unknown energy sources or chemical reactions occurring beneath their clouds? Or do these differences stem from their unique formation histories? The origins of Uranus and Neptune add another layer of intrigue. Formed in the outer regions of the solar system, where materials were scarcer and temperatures lower, their growth processes likely differed from those of the gas giants. Some theories propose that their cores might have formed closer to the Sun before migrating outward, while others suggest they could have captured material from the surrounding protoplanetary disk in unusual ways. Despite decades of study, Uranus and Neptune remain two of the least understood planets in our solar system. Their distance from Earth, combined with the complexities of their interiors, makes them challenging targets for exploration. However, future missions, such as potential orbiters or flybys, could provide the data needed to unravel these mysteries. Understanding these ice giants could not only shed light on their origins, but also provide insights into the formation of other planetary systems beyond our own. As we move forward in our journey through the solar system's unexplained phenomena, we'll next explore the curious case of Mars's moons, Phobos and Deimos, and the questions surrounding their origin. Now let's shift our gaze toward the red planet, where two small, enigmatic moons orbit Mars, adding yet another layer of mystery to our solar system. Phobos and Deimos, named after the Greek gods of fear and panic, are unlike any other moons we've encountered. Their strange shapes, irregular orbits, and uncertain origins have sparked decades of debate among scientists. Unlike the spherical moons of Jupiter or Saturn, Phobos and Deimos are small and lumpy, resembling potatoes rather than perfect spheres. Phobos, the larger of the two, is heavily cratered and scarred by a massive impact that created Stickney crater, a feature nearly half the size of the moon itself. Deimos, on the other hand, has a smoother surface covered in a layer of dust that softens its appearance. Despite their differences, both moons share a common mystery. How did they come to orbit Mars? One leading theory suggests that Phobos and Deimos might be captured asteroids, plucked from the nearby asteroid belt by Mars's gravity. This idea is supported by their composition, which closely resembles that of carbon-rich asteroids. However, their nearly circular orbits around Mars's equator pose a challenge to this theory, as captured objects typically have more irregular, tilted paths. Another intriguing possibility is that these moons are remnants of a much larger body that once orbited Mars. According to this hypothesis, a massive collision or gravitational disruption could have shattered this larger moon, leaving behind Phobos and Deimos as the surviving fragments. This would explain their shared orbital plane, but raises questions about what the original object might have been and how such an event could have occurred. Adding to the mystery is Phobos' slow but steady spiral toward Mars. Tidal forces are causing its orbit to decay, and scientists predict that within tens of millions of years, Phobos will either crash into the planet's surface or break apart, forming a ring around Mars. This impending fate makes Phobos a unique subject of study, offering a rare glimpse into the dynamic processes shaping planetary systems. Deimos, meanwhile, is gradually moving away from Mars, suggesting a different evolutionary path. These contrasting behaviors hint at complex interactions between the moons and their host planet, further complicating the puzzle of their origins. Despite their small size, Phobos and Deimos have captured the imagination of scientists and space enthusiasts alike. Missions like NASA Mars Reconnaissance Orbiter and ESA's Mars Express have provided valuable data, but many questions remain. Future missions, such as Japan's Martian Moons Exploration Mission, aim to collect samples from Phobos, potentially shedding light on its origins and, by extension, the history of Mars itself. As we continue our exploration of the solar system's unsolved mysteries, our next stop takes us to the Sun, where we'll investigate the baffling acceleration of the solar wind and the forces driving this powerful phenomenon. Now, let's turn our attention to the Sun, where another fascinating mystery unfolds: the acceleration of the solar wind. This stream of charged particles, constantly flowing from the Sun's atmosphere, reaches speeds of up to 1 million miles per hour, baffling scientists for decades. What drives this incredible acceleration, and why does it defy our expectations of how particles behave in space? One of the key challenges lies in understanding how the solar wind gains so much speed as it moves away from the Sun. At the Sun's surface, the wind starts relatively slow, but by the time it reaches Earth's orbit, it's traveling at a staggering pace. This acceleration shouldn't happen based on our current understanding of thermodynamics, yet it does. One leading theory points to the Sun's magnetic field as the driving force. The Sun's corona, its outermost layer, is incredibly hot, millions of degrees hotter than the surface. This intense heat energizes the particles, and the Sun's magnetic field acts like a slingshot, propelling them outward at incredible speeds. However, the exact mechanisms behind this process remain unclear. Another possibility involves waves of energy traveling through the Sun's atmosphere. These waves, known as Alfvén waves, could transfer energy to the particles in the solar wind, accelerating them as they move outward. Supporting this idea, observations from spacecraft like NASA's Parker Solar Probe have detected these waves close to the Sun, but their role in the wind's acceleration is still being studied. The Parker Solar Probe, which flies closer to the Sun than any previous mission, has provided groundbreaking insights into this phenomenon. By measuring the solar wind in its infancy, the probe has revealed complex interactions between particles and magnetic fields that could hold the key to solving this mystery. Yet, despite these advances, the full picture remains elusive. The solar wind's acceleration isn't just a scientific curiosity, it has real-world implications. This stream of particles interacts with Earth's magnetic field, creating auroras and occasionally disrupting communications and power grids. Understanding its behavior is crucial for predicting space weather and protecting our technology. As we continue to explore the Sun and its mysteries, one thing is clear. The solar wind's acceleration is a puzzle that challenges our understanding of physics and the forces at work in our star. With each new discovery, we come closer to unraveling this enigma, revealing the dynamic processes that shape our solar system. Next, we'll journey to Venus, where an even more extreme phenomenon awaits: the planet's runaway greenhouse effect and its thick, toxic atmosphere. Shifting our gaze to Venus, we encounter a world that defies imagination with its extreme and unforgiving atmosphere. Known as Earth's twin due to its similar size and proximity, Venus is anything but hospitable. Its surface is shrouded in a thick blanket of carbon dioxide, with clouds of sulfuric acid creating a toxic and suffocating environment. The pressure on Venus's surface is crushing 90 times that of Earth's, and temperatures soar to a scorching 860 degrees Fahrenheit, hot enough to melt lead. This hellish scenario is the result of a runaway greenhouse effect, a phenomenon that continues to baffle scientists. So, what exactly drives this runaway greenhouse effect? On Earth, the greenhouse effect is a natural process that helps regulate temperature by trapping some of the sun's heat. But on Venus, this process has spiraled out of control. The thick carbon dioxide atmosphere traps immense amounts of heat, creating a feedback loop that keeps temperatures rising. The result is a planet where surface conditions are extreme enough to obliterate any trace of water or life as we know it. But the mystery doesn't end there. Venus's atmosphere also moves at astonishing speeds. High above the surface, winds whip around the planet at over 200 miles per hour, a phenomenon known as superrotation. This means the atmosphere rotates much faster than the planet itself, a behavior that has no clear explanation. Some scientists suggest it could be driven by the intense heat and pressure differences, but the mechanisms remain poorly understood. The implications of Venus's runaway greenhouse effect extend far beyond the planet itself. It serves as a stark warning about the potential consequences of unchecked climate change on Earth. While Earth's atmosphere is vastly different from Venus's, the underlying principles are the same. Understanding Venus's extreme conditions helps us better grasp the delicate balance that keeps our own planet habitable. Studying Venus also offers insights into the diversity of planetary environments. Missions like NASA's Parker Solar Probe and the European Space Agency's Venus Express have provided valuable data, but many questions remain. Future missions such as NASA Veritas and Da Vinci aim to delve deeper into the planet's atmosphere and surface, potentially unraveling the secrets of its mysterious climate. As we explore Venus, we're reminded of the delicate nature of planetary systems and the fine line between habitability and chaos. Its extreme conditions challenge our understanding of atmospheric dynamics and offer valuable lessons for Earth's future. Next, we'll venture to the outer reaches of the solar system, where Pluto and its moon Charon present yet another cosmic puzzle. Now, let's journey to the far reaches of the solar system, where Pluto and its largest moon Charon present a fascinating cosmic dance. Unlike most planet-moon relationships, Pluto and Charon share a bond so unique that they're often referred to as a binary system. This means they don't just orbit each other in the traditional sense. Instead, they revolve around a common point in space known as the barycenter, which lies outside Pluto's surface. The formation of this pair is shrouded in mystery. Scientists believe that billions of years ago, a massive collision between Pluto and another celestial body may have given birth to Charon. The debris from this impact coalesced into the moon we see today, forever locking the two in a gravitational embrace. What makes this relationship extraordinary is their size. Charon is about half the diameter of Pluto, making it the largest moon relative to its parent planet in the solar system. This unusual size ratio contributes to their binary-like behavior. Most moons are significantly smaller than their planets and orbit at a distance, but Charon's size and proximity create a gravitational tug of war that influences Pluto's rotation. In fact, the two are tidally locked, meaning the same sides of Pluto and Charon always face each other as they orbit. It's as if they're locked in an eternal waltz, each forever gazing at the other. The Pluto-Charon system also challenges our traditional definitions of planets and moons. While Pluto was controversially reclassified as a dwarf planet in 2006, its relationship with Charon blurs the lines even further. Some scientists argue that the pair should be considered a double dwarf planet system, given their mutual orbit and balanced gravitational influence. Exploring this system has provided invaluable insights into the dynamics of celestial bodies. NASA's New Horizons mission, which flew by Pluto in 2015, revealed stunning details about both Pluto and Charon. The mission captured images of Charon's rugged surface, featuring canyons, craters, and evidence of ancient geological activity. These findings suggest that Charon, like Pluto, has a complex and dynamic history. As we study Pluto and Charon, we're reminded of the incredible diversity of the solar system. Their unique relationship challenges our understanding of planetary systems and invites us to rethink the boundaries of what defines a planet, a moon, or even a binary pair. Next, we'll turn our attention to the Dwarf Planet series, where mysterious bright spots continue to puzzle scientists. Now, shifting our gaze to the asteroid belt, we encounter Ceres, a dwarf planet that has captured the curiosity of scientists and space enthusiasts alike. Among its many intriguing features, the mysterious bright spots scattered across its surface stand out as one of the most perplexing phenomena in the solar system. These spots, first observed by NASA's Dawn spacecraft in 2015, appear as highly reflective areas within Ceres' Ocata crater and other regions. The brightest of these spots, known as Cerealia Facula, shines with a brilliance that contrasts sharply with Ceres' otherwise dark and cratered terrain. Initially, scientists speculated that the spots could be evidence of ice or frozen water. However, further analysis revealed a more surprising possibility. The bright material is likely composed of sodium carbonate, a type of salt commonly found in hydrothermal environments on Earth. This discovery has sparked intense debate about the origins of these bright spots. One leading theory suggests that they are the remnants of cryovolcanism, a process where water and other volatile substances erupt from beneath the surface. On Ceres, these eruptions could have brought briny liquid to the surface, which then evaporated, leaving behind the salt deposits we see today. This theory hints at the presence of a subsurface ocean or at least pockets of liquid water, raising questions about Ceres' potential habitability. Another intriguing possibility is that the bright spots are the result of ancient impacts. When asteroids or comets collide with Ceres, they could expose buried salt deposits or trigger subsurface activity that brings these materials to the surface. The Ocata crater, for instance, is relatively young in geological terms, estimated to be around 75 million years old, making it a prime candidate for such activity. The Dawn mission also detected a haze above the bright spots, suggesting that Ceres may still be geologically active. This haze, composed of water vapor and dust, could be the result of sublimation ice turning directly into gas when exposed to sunlight. This process further supports the idea that Ceres harbors water beneath its surface. As we continue to study Ceres, these bright spots serve as a reminder of the dynamic and complex nature of even the smallest bodies in the solar system. They challenge our assumptions about dwarf planets and open new avenues for understanding the processes that shape these distant worlds. Next, we'll delve into the enigmatic heat of the Sun's corona, a phenomenon that defies our expectations of stellar behavior. Turning our attention to the Sun, we encounter one of the most puzzling mysteries in our solar system, the extraordinary heat of the solar corona. The corona, the Sun's outer atmosphere, is scorching hot, reaching temperatures of millions of degrees far hotter than the Sun's surface, which averages around 5,500 degrees Celsius. This paradox, known as the coronal heating problem, has baffled scientists for decades. One leading theory suggests that the corona's extreme heat is driven by magnetic fields. The Sun's surface is a turbulent sea of magnetic activity, with loops and arcs of magnetic energy constantly shifting and reconnecting. These magnetic reconnections release enormous amounts of energy, potentially heating the corona to its staggering temperatures. Another possibility is that waves of energy generated by the Sun's churning plasma travel upward and transfer their energy to the corona. Studying this phenomenon, however, is no easy task. The corona is faint compared to the Sun's bright surface, making it difficult to observe without specialized instruments. Space missions like NASA's Parker Solar Probe have ventured closer to the Sun than ever before, gathering data to help unravel this mystery. Despite these efforts, the exact mechanisms behind the corona's heat remain elusive, as the processes involved occur on scales too small or too fast to capture fully. Understanding the solar corona isn't just an academic pursuit, it has practical implications for life on Earth. The corona is the source of the solar wind, a stream of charged particles that can disrupt satellite communications, power grids, and even pose risks to astronauts. By solving the coronal heating problem, we could gain insights into space weather and better protect our technology and infrastructure. As we continue to explore this enigma, the Sun's corona reminds us that even the most familiar objects in our solar system hold secrets waiting to be uncovered. Next, we'll explore the intense interaction between Jupiter and its volcanic moon Io, another extraordinary phenomenon that defies expectations. Now, let's dive into the dramatic relationship between Jupiter and its fiery moon Io. Io is the most volcanically active body in the entire solar system, a distinction that stems from its unique interaction with Jupiter. This tiny moon, just slightly larger than Earth's moon, is subjected to immense gravitational forces that stretch and squeeze its interior, generating enough heat to fuel hundreds of active volcanoes. Jupiter's gravity doesn't act alone in this process. Io also feels the gravitational pull of two other large moons, Europa and Ganymede, as they orbit Jupiter. These combined forces create a constant tug of war on Io, heating its interior through a process known as tidal heating. This relentless stress causes Io's surface to bulge and shift, triggering volcanic eruptions that spew molten lava and sulfur compounds into space. The volcanic activity on Io is so intense that it constantly reshapes the moon's surface, covering it with vast lava plains, towering volcanic peaks, and colorful deposits of sulfur and silicate rock. Some of these eruptions are so powerful that they can be seen from Earth with powerful telescopes. Studying Io isn't just about understanding one moon, it provides insights into the dynamics of other worlds. Tidal heating is thought to play a role in the potential habitability of moons like Europa and Enceladus, where subsurface oceans might exist beneath icy crusts. By unlocking the secrets of Io's volcanic activity, scientists can better understand how similar processes might operate elsewhere in the solar system. The Jupiter-Io system also offers a glimpse into the complex interplay between a planet and its moons. Jupiter's immense gravity doesn't just shape Io's surface, it also creates a magnetic field that interacts with Io's volcanic plumes, generating electric currents and auroras in Jupiter's atmosphere. This interaction has been observed by spacecraft like NASA's Juno mission, which continues to study the intricacies of this dynamic duo. As we wrap up our exploration of this fiery phenomenon, Io serves as a reminder of the incredible forces at work in our solar system. Its volcanic eruptions, driven by the gravitational dance with Jupiter, highlight the interconnected nature of celestial bodies and the endless surprises they hold for us to discover. Shifting our gaze to the far reaches of the cosmos, let's revisit the enigmatic phenomenon known as the dark flow. This mysterious force, first detected in the early 2000s, reveals galaxy clusters moving in a specific direction at incredible speeds, defying the known laws of gravity and cosmology. While the cause remains a puzzle, scientists believe it may be linked to the large-scale structure of the universe itself. One leading theory suggests that the dark flow could be influenced by massive structures beyond the observable universe, regions of space so distant that their light has not yet reached us. These unseen regions might exert a gravitational pull on galaxy clusters, creating the observed motion. Another possibility is that the dark flow is a remnant of the early universe, a ripple left over from the inflationary period that followed the Big Bang. The dark flow challenges our understanding of how the universe is organized on the largest scales. It raises questions about what lies beyond the cosmic horizon and whether our observable universe is just a small part of a much larger, perhaps infinite, cosmos. Some researchers even speculate that the dark flow could be evidence of other universes, part of a vast multiverse exerting gravitational influence on our own. Studying the dark flow isn't just about solving a cosmic mystery, it's about reshaping our understanding of the universe's architecture. By mapping this phenomenon, scientists hope to uncover clues about the distribution of matter and energy on the grandest scales, shedding light on the forces that have shaped the cosmos since its inception. This exploration of the dark flow reminds us that the universe is full of unanswered questions, each one a doorway to new discoveries. As we continue to probe the depths of space, phenomena like this challenge us to rethink what we know and imagine what might lie beyond the limits of our current understanding. Turning our attention from the vast mysteries of the cosmos, let's zoom in on a single moment in history that has sparked decades of fascination: the WOW signal. Detected on August 15, 1977, this peculiar 72-second radio burst has become one of the most famous and enduring mysteries in the search for extraterrestrial intelligence. Originating from the direction of the constellation Sagittarius, the signal's intensity was so remarkable that astronomer Jerry Amon famously circled it on the printout and wrote, "Wow." Beside it, what makes the WOW signal so intriguing is its characteristics. It was a narrowband signal, meaning it was concentrated in a very specific frequency range, which aligns with what scientists predict an alien transmission might look like. The frequency matched the hydrogen line, a key wavelength in space communication, further fueling speculation about its origins. Despite numerous attempts to detect the signal again, it has never been observed since, leaving its true nature shrouded in mystery. The WOW signal has become a cornerstone in the search for extraterrestrial intelligence, often referred to as SETI. It serves as a reminder of the possibility that we are not alone in the universe and that advanced civilizations might be attempting to communicate across the stars. SETI researchers continue to scan the skies for similar signals, using increasingly sophisticated technology. Projects like the Breakthrough Listen initiative aim to analyze millions of stars and galaxies, hoping to catch another WOW moment that could change our understanding of life beyond Earth. Some theories suggest the signal could have been a natural phenomenon, such as a comet or a distant star emitting a rare burst of radio energy. Others argue it might have been an artificial transmission, a deliberate attempt by an intelligent species to make contact. The debate remains unresolved, and the WOW signal stands as a tantalizing hint that we may be on the brink of discovering something extraordinary. This enigmatic burst of energy challenges us to consider our place in the universe and whether we are truly alone. It underscores the importance of continued exploration and the need to keep looking to the stars for answers. As we reflect on the WOW signal, we're reminded that the search for extraterrestrial life isn't just about finding answers, it's about asking the right questions and staying open to the infinite possibilities the cosmos holds. Shifting our gaze from the mysteries of distant signals, let's delve into a phenomenon much closer to home: the moon's mysterious magnetic field. While our moon today appears as a silent, airless world, its past tells a different story. Billions of years ago, the Moon may have had a magnetic field similar to Earth's that has since vanished. This discovery has puzzled scientists, as the Moon's smaller size and cooler interior should, in theory, make such a magnetic field impossible. So, what could have caused this ancient lunar dynamo, and why did it disappear? One leading theory suggests that the Moon's magnetic field was powered by its molten core, driven by intense heat left over from its formation. Early in its history, the Moon was much closer to Earth, and the gravitational forces between the two bodies could have stirred the Moon's interior, creating a dynamo effect. As the Moon gradually moved farther away and its core cooled, the magnetic field weakened and eventually vanished. This theory not only explains the Moon's past magnetism, but also provides clues about its geologic evolution, including the formation of its ancient crust and the distribution of minerals. Another intriguing idea points to massive impacts during the Moon's early history. Some scientists believe that colossal collisions, such as the one that formed the Moon's largest basins, could have temporarily generated a magnetic field by shaking up its molten core. These brief but intense periods of magnetism might have left behind traces in the Moon's rocks, which we can study today to piece together its geologic timeline. Understanding the Moon's magnetic field isn't just about uncovering its past, it also has implications for future exploration. Magnetic fields can shield a planetary body from harmful solar radiation, making them crucial for sustaining life or supporting human habitation. If the Moon once had a magnetic field, it raises questions about whether it could have supported an atmosphere or even liquid water in its early days. This knowledge could guide future missions, helping scientists identify the best locations for lunar bases or resources. As we prepare to return to the Moon with ambitious programs like NASA's Artemis mission, studying its magnetic history becomes even more critical. By analyzing lunar rocks and mapping its ancient magnetic fields, we can uncover secrets not just about the Moon, but about the early solar system as a whole. The Moon's magnetic field may be long gone, but its story continues to reveal the dynamic and ever-changing nature of our cosmic neighborhood. From the enigmatic dark flow pulling galaxies across the cosmos to the haunting silence of the WOW signal, these 25 unexplained phenomena remind us just how much we have yet to discover about our solar system. Each mystery, whether it's the hexagon on Saturn or the missing baryonic matter in the universe, challenges our understanding and pushes the boundaries of science. These phenomena aren't just curiosities, they're invitations to question, explore, and imagine. What could be causing the Tunguska event's mysterious explosion or the strange bright spots on Ceres? Could the Martian methane hint at life, or is it just another geological puzzle waiting to be solved? As we've journeyed through these cosmic enigmas, one thing is clear: the solar system is far more complex and dynamic than we often realize. Every unanswered question is a reminder of how much more there is to learn and how much more there is to explore. So, what do you think about these mysteries? Do you have a favorite phenomenon or a theory of your own? Share your thoughts in the comments below. We'd love to hear your ideas and spark new conversations. If you're fascinated by these cosmic puzzles, don't stop here. Our universe is filled with countless mysteries waiting to be uncovered. Hit that like button, subscribe to our channel, and turn on notifications so you never miss an exploration into the unknown. Together, let's keep unraveling the secrets of the cosmos, one mystery at a time. Thanks for watching, and remember, the universe is vast, but curiosity knows no bounds. Stay curious, and we'll see you in the next adventure.